Comets are remnants from the formation of the solar system, preserving material from the time when the sun and planets were forming about 4.6 billion years ago. When sunlight warms their frozen surfaces, gas and dust escape from the nucleus and form a cloud-like structure called a coma. Some of that material forms tails stretching through space, reaching our eyes as something beautiful. Some comets come from the Kuiper belt, a distant region beyond Neptune. It contains many icy small bodies, dust, and rocky objects that can become the material of comets. And Pluto is one of the representative objects that belongs to the Kuiper belt. Other comets may come from the Oort cloud, a collection of icy small bodies thought to surround the solar system in a spherical shell. However, the Oort cloud has not been directly observed. It is a region whose existence is inferred to explain the orbits of long-period comets. NASA explains that the Kuiper belt and the even more distant Oort cloud may contain billions or more comets orbiting the Sun. Most of them never come close to Earth, but gravitational interactions can change a comet's orbit, and a very small number may cross Earth's orbital path. So what would happen if one of those comets hit Earth? Earth has already been changed by objects from space. The best-known example is an asteroid. About 66 million years ago, an object struck near what is now the Yucatan Peninsula in Mexico and formed the Chicxulub crater. That impact released enough energy to alter the climate, and it is linked to the mass extinction that ended the age of non-avian dinosaurs. The Chicxulub impactor is now generally understood to have been an asteroid. Asteroids are mainly rocky or metallic bodies, while comets contain large amounts of ice and volatile material, even with different properties, when they reach Earth at high speed. The main source of destruction is the same. In 1908, an object exploded in the atmosphere above Tunguska, Siberia. NASA describes this event as an asteroid airburst. Trees were flattened for miles, causing enormous damage. In 2013, another object entered the atmosphere above Chelyabinsk, Russia. It exploded high above the ground, and the shock wave damaged buildings and shattered windows across a wide area. NASA reported that more than 1,600 people were injured, most of them by broken glass. So what about comets? The strongest modern example of a comet impact happened on Jupiter. In 1994, comet Shoemaker-Levy 9 broke into multiple fragments and collided with Jupiter over several days. The impacts were directly observed by spacecraft and telescopes. Dark scars appeared in Jupiter's atmosphere, some of them larger than Earth. But on Earth, comets have left fewer confirmed scars. That is because, unlike near-Earth asteroids, they can suddenly enter the inner solar system from far away, because Earth has so few records of them. If one of those rare visitors truly began moving toward this planet, humanity would still have very few real examples to study. When a comet hits Earth, the first thing that happens is an orbital crossing. Earth and the comet are both moving under the gravity of the Sun when those two orbits cross, and Earth and the comet arrive at the same place at the same time. An impact occurs. A comet from a distant region, such as the Oort cloud, can have its orbit disturbed by the gravity of a passing star, the galactic tide, or interactions with planets, an object that has spent a long time in the outer solar system. can be shifted onto an orbit falling toward the Sun. Comet Sighting Spring is an example of that process. This comet was discovered in January 2013 and made an extremely close approach to Mars in October 2014. NASA reported that the comet's nucleus passed about 139,500 kilometers from Mars. The comet's dust particles were moving at about 56 kilometers per second. Spacecraft orbiting Mars were moved into safer positions to avoid dangerous dust. But the orbit missed, and the comet did not hit Mars. If a similar object were heading toward Earth, when we could know about it would depend on the conditions at discovery. If the comet were bright and active, it could be found while it was still far from the Sun, giving months, or in some cases more than a year, to calculate its orbit precisely. But if the object were dark and approaching from the direction of the Sun, the time available to humanity could shrink to months. NASA's planetary defense research also treats long-period comets and interstellar objects as more difficult to respond to than near-Earth asteroids, because they can provide shorter warning times. For comets, speed is especially dangerous. If a comet entered Earth's atmosphere at tens of kilometers per second, its kinetic energy would be enormous. When a comet reaches Earth, the first disaster begins before it touches the ground. The comet enters the atmosphere at tens of kilometers per second, and the air in front of it is violently compressed. The surface of the comet heats and begins to lose material. Even an object around 20 meters wide can break windows and damage buildings across a wide area if it explodes above a city, in a major urban region, an area where hundreds of thousands or even millions of people live, can fall within the zone of impact. An object 100 to 200 meters wide would not be limited to damaging part of a city, even if it exploded in the atmosphere. The blast could spread across tens of kilometers, and if the comet is large enough to survive atmospheric entry, it releases its energy in a single moment when it reaches the surface. At the impact point, the surface is excavated and a crater forms. Thermal radiation ignites fires across a wide area. The sky becomes brighter than it should ever be, and then darker than it has any right to be. If the comet strikes land, pulverized rock and dust are thrown upward, and some material reaches high into the atmosphere. Some of it can even leave the atmosphere and fall back across distant regions. And if the comet strikes the ocean, a large ocean impact displaces an enormous volume of water and generates tsunamis that cross ocean basins. For a kilometer-scale comet, the true damage becomes planetary. Dust, aerosols, water vapor, and impact debris enter the atmosphere, and sunlight reaching the surface decreases. Photosynthesis weakens, and plants are affected first. That effect then spreads to the animals that depend on plants, and to the food systems built by humans. The first few minutes after a comet impact belong to flash, blast, heat, earthquakes, and waves. The first few days belong to medical collapse, communication failure, evacuation, and supply shock. The first few months belong to climate change, hunger, and political stress. The direct impact takes what is nearby, but the atmosphere carries the disaster into the world. That is the true scale of a comet impact. When a comet impact is discovered as a real threat, The first problem humanity faces is information. If the discovery happens several months or more before impact, the predicted impact point can be narrowed down, giving potentially affected regions time to prepare. At this stage, preparation still has the shape of society. But if the warning comes only weeks before impact, the world becomes something else. Traffic could become completely paralyzed by people desperately trying to evacuate, and lives could be lost to conflict between humans before evacuation even begins. And if damage on that level is expected, whether that information would be released to the public at all becomes a serious question. A scientific threat should be shared transparently, but in reality, information has the power to create disorder. When a comet moves toward Earth, humanity has to control not only the object, but information itself. So if people know in advance, where do they go? For a small object, the answer is to move as far as possible from the predicted impact area, or any location expected to be dangerous. But for a kilometer-scale comet, or something larger, people can move away from the impact point, but they cannot escape Earth after the impact. When Earth itself becomes a planet that can no longer give life the same blessings as before, safety no longer exists on a map, and the greatest danger may be the humanity left behind after the shock delivered by the comet. Those who have and those who do not. That boundary would become clearer than ever, creating a world where lives are selected if humanity had no means to respond. This would become the worst scenario produced by the civilization we built. But if there is enough time before impact, changing the orbit of a comet or asteroid becomes an option. NASA's DART was launched in November 2021 and struck Dimorphos, a moonlet of the asteroid Didymos, in September 2022. As a result, the time Dimorphos takes to orbit Didymos was shortened by about 32 minutes. DART's target was a binary asteroid system that could be observed well in advance, so the same method cannot necessarily be applied directly to comets under different conditions. But DART proved that if there is enough time, and if the object's orbit and properties are understood, humanity can change the motion of a celestial body. Other methods are also discussed, including changing an object's orbit slowly through gravity, or in extreme cases, using a nuclear explosion to alter its path. But comets are faster than asteroids and can come from much farther away, making any response more difficult in a comet impact scenario. The question left for humanity is simple. Can we find the natural threat early enough to stop it? Can science advance far enough to stop it? A disaster from the sky tests Earth. But what is truly tested is how long humanity can remain a civilization on that Earth.